to warm up here, I'm going to give you a 2 cosine of 4x minus pi over 3 plus 5. And it asks for the amplitude, the period, phase shift, midline, and then you're supposed to graph it. Okay, so can you tell me the amplitude of this?
Is it 2?
Yes.
Okay.
The period is 2 pi over b. Do you know what the b value is in this equation?
4 or
4. 2 pi over 4. Oops, or b again. And that reduces to pi over 2.
okay.
And then phase shift, whenever x has a 1 in front of it, it's just this number here. If this 4 was distributed in, you'd have to back it out. So you have to just be careful of that. It's pi over 3, but is it right or left? It's based on that there. Do you recall?
It's gonna be right.
That's right, yeah. The midline or the vertical shift is this plus 5. And then do you know if you're going to have to graph these by hand or use technology or something else?
I think he'll give us like a grid, but then we do it by hand.
Okay. This one would be pretty messy to graph, but we can do it. Do you think do you anticipate being expected to graph something like this? This complicated. This has everything in it. It's got, all these. Sometimes they only ask you to graph the ones that have a few things going on.
Yeah, probably not something this complicated.
Okay.
I'm like, I know what it looks like, so.
All right. So this section does cover graphing of other functions, trig functions besides sine and cosine. It also covers secant and cosecant. And to graph these, you end up having to graph the sine or the cosine and then connecting it. And then there's also tangent and cotangent. Hopefully this is all familiar to you.
Yeah.
Okay. Let me go back to 13.7. These seem to be more, I think these are more, okay, so there are some graphing ones here. So let's graph y equals 2 tangent pi x. Okay, so the key things that you need to know about tangent is its shape. And the first thing you can do is, do you know what tangent looks like?
Yeah,
Without,
it's kind of like cubics, but they're not cubics.
it kind of goes up and to the right. So there's vertical asymptotes, and do you know where those occur in the standard one?
No.
So pi minus pi over 2 and pi over 2. So you really need to know the parent function to be able to do these.
Okay.
And this is pi apart, which is the period.
Oh, okay.
This one though does not have a period of pi. The period for a tangent or a cotangent is not 2 pi over b, it's just pi over b. So in this case, your b value is pi, so its period is 1. Do you follow that, how that changes?
Yeah.
Okay, so then what that does is it changes the graph, meaning it changes like where, so the width is 1. So like this is where it gets a little bit awkward because like this could be -1, this could be +1, this could be a half, minus a half, this could be a half. So if the width is 1, your asymptotes are here.
Mm-hmm.
And then it has this shape again like this.
Yeah.
The 2, all the 2 does is it just stretches it. And depending on whether you have to label points or not, that's where it can get a little bit tough. But if you're okay to just kind of make a sketch that's close, it's probably enough for you to do to make it clear that you understand this.
Mhm.
Um, okay, so let's do a cotangent. Y equals minus 2 cotangent 1/2 x. Okay, so do you have an idea of what cotangent looks like?
Is that the one that's like a, a
It goes the other, it kind of goes, it goes the other way, but it starts here. It goes the other way,
oh,
and it's normally, this is why you gotta know these things to be able to graph them on the exam. That's why I asked if you had access to technology, because if you do, you kind of know the answer, right? This is pi right here, and it has this shape to it.
yeah.
All right, and I've kind of not drawn it great, but it's very similar to tangent, but it's kind of moved around a little bit.
Mhm.
The period here is pi. So the period here is pi over b. B is 1/2, which is 2 pi.
Okay.
All right. So now what that does is it moves this. So like instead of it being at from 0 to pi, it moves it out to 2 pi. And it still has this shape to it before we do the other things to it. So the period affects, like, kind of, it's a horizontal stretch or pull.
Mhm.
Okay. Now, you could also um, you also have to deal with this 2 and this negative. The 2 just kind of pulls it up. It's hard to actually describe. What does the negative do, though?
But flips it.
Yes. So it would look something like this.
Oh, okay.
So all the rules that you know before, like negative out in front, what does it do? What does the period do? It all affects these graphs here as well. Um, just again, I'm just kind of struggling here a little bit to know exactly what to go through, because there's so
Yeah.
much. You really need to. Um,
Can we just go over like secant and cosecant? Because I know sine and cosine.
sure. So we'll graph y equals -2 cosecant x. Let's go. Let's go 1/4 x, like that. So the graph that you make is you convert this to a sine. You say, okay, well, it's really 1 over sine 1 over 4 x. So you really got to graph this first, the sine. So what does the 1 over 4 do? Well, it changes the period. The period is 2 pi over b. B is 1/4. So the period is 8 pi.
Oh, okay.
All right. So what does that do? Well, let's graph one wave of sine. So this is where it gets tricky, because it like, you're not tricky, but it's like it's I can just call this 8 pi, but maybe on your graph 8 pi will be out here.
Mm-hmm.
Okay. And we need to, because it's cosecant or cotangent, you definitely need to go out more than one period. So that's 16 pi. Okay. Now, if there was some other stuff going on here, like if there was, I don't know, if there was like um, well, there's nothing else going on here, so we can leave it at that. So these places where it crosses the x-axis, those are these vertical asymptotes.
Okay.
So I'll do it in red here. The first sort of shot at what this looks like is something like this. Okay.
Yeah.
And then it's like, well, what does the negative do? The negative the negative flips it, but we really need to deal with this 2 here in front of the sign, because you can do it either way. Like we could actually convert, let me delete these. We could actually convert the sign to the negative. So we could put a -2 here, and what would that do to the sine wave? Well, it would flip it. And then what does the 2 do? It would pull
Like
it.
make it taller.
Yeah, it would do this kind of, it pulls it in these various directions. But notice your asymptotes don't change. But what it does do is it changes where the u's go. Sorry, this don't know why it did that. So the u's are now like this, 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 and so on.
Okay.
But you said, hey Matthew, I know how to graph sine and cosine. If you really do, then this graph in red here should be very clear, because
Yeah.
the cosecant is just a change on that. All right, let's do a secant. Let me change the pen colors back here. So let's do a y equals secant pi x minus 1. Okay, so we gotta graph this. We gotta graph, well, what does secant do? So
It's the
it's
same
1
thing.
over cosine, right? 1 over cosine pi x. And I'm making a little change here. The period is 2 pi over pi, so it's 2. So that means that cosine, which starts high and goes low, okay, well, this is one period. That's 2. So that's 1. And your graph might be that 2 is literally 2 boxes, but I can arbitrarily choose that. Like, you might have to squeeze yours into this little region. I don't know which instructor will have you do. Okay. But we need to graph more than one period, because these things, you just don't get enough of the shape of it without that.
Yeah.
So now we got this. These are where it crosses. But what about this -1 thing? Well, we got to be careful here, because if 1 over it's where 1 over cosine is undefined, not this -1. Okay,
Does
it's
that
these.
just
It's
move?
Say that again.
Does it just move it down?
It will, but not. I don't want to. How do I? I'm gonna get the right words here.
Not yet.
Yeah, you got to be careful of not doing it too soon. So
Uh-huh.
let me see if I can find a picture. So the because if you were to move this down, it changes where it hits. Like what I'm trying to say here. If we were to move this graph down, then this point would be here at the origin, and that's where an asymptote would be. But that's not true. So the asymptotes are fixed. Then you move it down. So once you get the asymptotes, then you can move everything down, and
Oh,
that'll help you to get the.
yeah, that makes sense.
So the in terms of, like, you can graph this, but your asymptotes have to come from just what I've circled, not from the whole thing.
Because they would be at like a different
A
place
different value.
based
Yeah,
off the.
exactly. So let me just snip in the picture that I've got here in Desmos. That'll really make this clear. Graphing by hand is it's really antiquated, but that is what they have you do. But you'll see here that the asymptotes are still where this is before you subtract 1. And there's one example. I'm sorry, like right there. There's still an example of 1, but you have to move the cosine down to get where it hits with the u's.
Yeah.
There's so many variations on this, but that is everything. Are you comfortable using sine regression on your calculator?
Sine regression?
Yeah, one of the one of the slides here says sine regression.
I don't even know what that is.
Let me snip it here. This is from 13.6 to 13.7.
Oh.
Like, this goes in L1, this goes in L2, and then you have a regression for it. Yes, no, maybe.
I can't find. Is it in stats?
Yeah, let me look for it here. Sine regression. Stat button.
Oh yeah, yeah. I found it.
Yeah, stat. Oh, Did you find it?
Yeah.
Okay. Okay. So you have to put your data in, and then you do it that way.
Mm-hmm.
All right. Let's see. Go back to the notes. All right. Let's do some stuff with angles, I guess.
Okay.
All right. All right. So let's say I give you 315 degrees. How do you convert this to radians?
The like pi over 180 or
Times
something.
pi over 180. Yeah. And if you have a calculator, you can put this part in, and it'll reduce, but not the part with the pi,
Uh-huh.
because that won't reduce.
Okay.
So if you've got a calculator, go ahead and grab that and put that in and see what it reduces to.
I got 1.75 pi.
So that is 7 pi over 4. You want to do the math? Enter, enter, to get it into a
Okay.
fraction there. Okay. What is the reference angle for that? And if you recall, the reference angles are always the angle made with the x-axis. Where's 350 degrees? 0, 90, 180.
The fourth quadrant.
It is in the fourth quadrant. It's right in the middle here. So it's the angle made with the x-axis. What is that angle? How much of that angle is there? It's 45 degrees.
Okay.
So the reference angle is 45 degrees, or what is that as in radians? What's 45 degrees in radians?
7. Oh, is it? Oh, okay. 45. 1/4.
Pi over 4, yeah. Great. Okay. Now let's find a coterminal angle. So how do you find coterminal angles with, say, 7 pi over 4? There's two options. You can either add 2 pi or you can subtract 2 pi. Usually you're asked for like one positive or one negative coterminal angle. So you have to do both of these. So how do you combine 7 pi over 4 and 2 pi? Do you recall?
You get it to be the same denominator.
You can, yep. And you can also use your calculator, just don't put the pi's in. So this is like 8 pi over 4. So it's 15 pi over 4. And this is like saying subtracting 8 pi over 4. So that becomes minus pi over 4.
Oh, okay. So it's 14 pi over 4.
Which one?
Oh, never mind.
Nope.
There's
So this
this
is
thing.
your negative coterminal on the right, and this is your positive coterminal on the
Oh,
left.
they're like the same. It's just
Yeah, that you get one of each. Most likely you'll see. So let's try another one here. Let's say I give you negative 570 degrees. I want one positive and one negative coterminal angle for each for this.
in radians or
In degrees. Degrees will be fine. Then we'll convert
okay.
it.
Okay, so there's negative 210.
Right? This time you got to keep going. You got to just add 360 again.
Yeah, and 150.
All right, so I want you to convert minus 210 degrees and 150 degrees to radians.
Oh, okay. Okay, I got negative 7 over 6 pi
Good.
for negative 210. And then 150 is 5/6 pi.
That's right. Great. Okay. Now let's figure out what the reference angle is for each of these. So in the case of, and we got to do it in radian because most of the time that's what you're going to see. So 5 pi over 6, we'll do this one first. 0, pi over 2, and pi. Well, where's 5 pi over 6? Well, the challenge is this doesn't have a 6 in the denominator, but you could change it to 6 pi over 6. And this would be like, up here, this would be like 3 pi over 6. So where does 5 pi over 6 fall? It falls right about there.
So that's like the 30 degrees?
But what is it in radian?
Oh, to pi over 6?
It is pi over 6.
Okay.
Okay. Now minus 210 degrees, we're going to do that way. That's 0. That's minus 90. That's minus 180. That's minus 270. Notice it is right there. What is its reference angle? The one made with the x-axis.
30, right?
30 degrees again. The reference angle is always positive.
Okay.
So that's important to remember. No matter whether it's positive angle, negative angle, the reference angle is always positive.
Got it.
Got it? Okay. Just trying to find a few more things here. Now, will you be given a unit circle for this quiz test, whatever you got?
I don't think so. I think we just get a calculator for part of it.
Okay. So have you heard any words like, "Hey, you need to know the unit circle for the first quadrant," or anything like that?
Yeah, I would say just that maybe just the first quadrant.
Okay. So let's remind you. There's a few places that are really important here. The first is this one over here, all to the right, and to get there, it's 1, 0. And this one straight up is 0, 1. These are just ordered pairs. This first one, I know you like to call it 30 degrees, but it's really pi over 6. That's preferred. And there's two values you need to know. Square root of 3 over 2, 1/2. X is the cosine, y is the sine.
Yeah.
Okay, and then this middle one is square root of 2 over 2. And then this one up here is 1/2, square root of 3 over 2. So for example, and these are the most basic questions. I could just say, what's the cosine? Oh, these are 45 and pi over 4. This is 60 and pi over 3. I could say, what's the cosine of pi over 3? And you say?
Pi over 1/2.
1/2, okay. But that's too easy because you're just looking them up. So I could ask, I'd say, what's the cosecant? What's the cosecant of pi over 6? And you would need to know that cosecant is 1 over sine pi over 6. And what's sine of pi over 6?
1 over 1/2, and then pi times pi over. Wait, 1 over. I don't.
Sine is the y value.
Yeah, so it's just 1 over 1/2.
Which is 2.
Oh, 2. Okay.
Okay. So your instructor could be very kind and just ask you for the straight. You could ask for just these direct ones, but I think you're more likely to see some of these other ones. So like let's say I ask for the tangent of pi over 3. Tangent is sine over cosine, right? So it's y over x. So it's like square root of 3 over 2 over 1/2. And then you'd have to be expected to be reducing that.
Which is just root 3, right?
Yes. So that's not too bad because you can just look those up. One that might be more difficult is the tangent of minus pi over 2, because you have to know where that is on the unit circle. And I'm hoping you can tell me where that is, because it is kind of a nicer point.
So you have to go backwards?
Right, so here's 0, right? And you're going this way. And this is minus pi over 2. Because normally you go positive,
Oh, it's just,
and there's pi over 2.
so it's 0, -1.
So 0, -1 there. Exactly. Now, tangent is y over x.
-1, it's undefined?
It is undefined.
Okay.
So then I could say, well, what's the cotangent of minus 180 degrees?
Cotangent is cosine over tangent?
It's 1 over tangent or cosine over sine. So
Oh,
it's x over y.
so that's -1, 0. So it's just -1.
What's the x value there at this place? Minus 180.
-1,
And what's the y value?
0. Oh, it's
Undefined.
sorry.
Yeah. So notice it's really easy to make some mistakes here, even though they're not. I'm not giving you any of the ones that are harder to remember for that. So what I can't do is I can't tell you how much to remember on the unit circle. You just got to be. You have to decide that or know that ahead of time.
ASTC.
Yeah,
I
ASTC. Yeah.
remember that part.
Yeah. So that's really helpful when we're trying to figure out the reference angle and whether it's positive or negative. So the classic question here is, I want the cosine of 150 degrees. This is equal to plus or minus the cosine of the reference angle. So what is the reference angle for 150 degrees?
It's 30? Pi over 6.
30 or pi over 6, right? So then it's plus or minus, and that comes from this all students take calculus.
Oh, so it's -30 because the cosine is negative.
That's right. So this is really negative cosine of 30. So then now you can say, oh, I got it. I know what it is. Cosine of 30 is square root of 3 over 2. That's negative. Okay, but that was in degrees. I mean, that's kind of a nice one. Really, I mean, I could ask you for the tangent of, let's see, like 5 pi over 4. And you would need to know where that angle is. And then you'd want to know the reference angle. So in the
that's a 45-degree one?
Well, it's here. So what's the reference angle? Yeah, it is. It is 45 degrees. So it's all students take calculus ASTC. So tangent positive or negative here?
Positive.
So it's positive tangent pi over 4. So then you got to know what it is in the first quadrant. Do you know that?
Pi over 4.
Sine over cosine. And you're welcome to pull one up. Have I sent you the reference sheet?
Yeah.
If I need to, I can send it again. But it'd be good to have that out. It ends up being the square root of 2 over the square root of 2, which is equal to
square root of 1. Just a 1. Okay. Yeah, that makes sense. It's just a lot of things to remember.
Yes. Right. All right, we need to do some converting to degrees, minutes, and seconds. And because I could see that being a question that comes up on here. So let's say I tell you it's 105.23. Hang on just a second, I'll be right back.
Okay.
All right, I'm back. So we're going to convert 105.23 degrees to minutes, degrees, minutes, and seconds.
That's a thing. Okay.
Sorry, say that again.
I did not know that was a
Yeah, I
thing.
mean, I'm looking at it right here on your slide. I mean, maybe.
I zone out. His class is like the most boring thing ever. We just look at these slides.
Well, I mean, that's something I can't help with. You could express your concern to your mom, and maybe she can talk to the school. But um, so the degrees is always this part. It always is that part. Okay.
Okay.
The minutes, you take this number 23 and you multiply 0.23, sorry, and you multiply it by 60. So do you have a calculator?
Yeah. 0.23. That is, oh,
So I get 13.8.
yeah.
So that 13 is your minutes. So we got 105, 13. And now you take that 0.8, okay, and you multiply it by 60, and that becomes your seconds. Now it happened to work out perfectly. I actually don't know what you do if it doesn't work out perfectly, but I think it probably will for you on your exam.
Yeah, it's kind of fun.
Okay, so you're going to do one here. So let's say it's 47 point, what did I choose up here? Point 72. So why don't you convert that to degrees, minutes, and seconds?
Okay, so it's 47 degrees.
Okay.
And then it's 0.72, 43.2 minutes.
So it's only the first number. It's the 33.
43.
I'm sorry, 43. And then you take the whatever's here and you multiply it by 60.
Oh, okay. So 0.2, 12.
All right. So did it work out perfectly?
I think so.
There was nothing left over? Okay, good.
No, it's just 12.
All right. So now we're going to go backwards. Okay. And this could be, it's not meant to be complicated, but it's just a little bit, it's different, obviously. So to go backwards, you take your degrees and you add your minutes. Actually, let me write out the formula, and then you can. So you take your degrees, you add your minutes divided by 60 plus your seconds divided by 60 squared. So in your case, it's 47 plus 43 over 60 plus 12 over 60 squared. Do that and you should get back to the original, and then we'll go do another.
What is this used for? Like some rocket science thing?
It used to be used in when we traveled by sea about 400 years ago.
And I'm doing it in that class.
Yeah, I don't have a good answer. Sorry.
Oh, it worked.
Yeah. So let's do one more so you can see that. Your formula is degrees plus minutes divided by 60 plus seconds divided by 60 squared.
Okay. $13. Yeah, worked.
Worked. Okay, so that you got to be able to do that. That's probably a quick calculation
Mhm.
on there. Do you know if you did anything with circumference or area in this section, chapter, book?
Not that I know of.
Okay. Um, all right, we have about 10 minutes left, a little over that. Is there anything that I haven't covered that you would like to make sure we cover?
I think we got it all.
Okay.
Yeah.
Any homework questions that you couldn't do that you need to look at again?
Nope. All of our homework has been very minimal.
Okay. We did a chapter review. I'm not trying to dodge or defer, just trying to make sure is there, we did a chapter review
Yeah.
last time. Is there, do you want me to pull that up and see if there's something in that, um,
Mhm. Um, I think it was mostly just graphing.
a lot of graphing?
Yeah. Okay, I'm looking at it right now. I mean, there was nothing that really like shocked me in it. I turned it in. Yeah, I feel like I know how to do all of this stuff. Yeah. Yeah, we're good with that.
Okay.
Yeah.
Well, um, let's do something. I'll pull up some test prep stuff, and you can you can try a couple of questions here. I'll try to choose some that are maybe somehow related to what we're doing here. Okay, here is a good one for us to start with, and it's just it's got some fractions in it. We did some fractions here, so take a look here. All right, so if I'm sorry, 1 over k plus 1 over 4k plus 1 over 3k equals a. If k equals 1/5, what is the value of 1 over a? So the first step here is you're going to substitute this 1/5 in for k.
Yeah.
So it's 1 over 1/5 plus 1 over 4 times 1/5 plus 1 over 3 times 1/5 equals a. So this is where there's a skill here where if you don't have to write it, it saves you a ton of time. Do you know what 1 over 1/5 is?
No.
It's 5. So it's
Oh.
the reciprocal of this bottom fraction.
Oh, okay.
So right here, this is 4/5. So 1 over 4/5 is 5/4.
Oh.
And then this is 3/5, and 1 over 3/5 is
5
5/3.
thirds.
So how do you add three fractions with unlike denominators?
Make them.
You make a common one. Okay, so here this is 60 because you're multiplying top and bottom by 12. Here it's 15, and then here it's 20. So I want you to add these all together. This is a no calculator problem, by the way.
Yeah, 95. And I did it all in my brain. Okay.
Now that's not the answer though, because the answer here, it actually wants 1 over a. That's one of the things you have to be really careful about because it very misdirects you. And then you say, oh, I should have known that. Yeah. So it's 12 over 95 is the answer here.
Okay.
Let me see. So I've got one just like it that you can do. Let me see. That one might be a little bit too difficult. All right, let's have you try this one. All right, so go ahead and take a look here. It's the same steps as before, but it's obviously different numbers. So just give it a shot, and I'll give you about 60 seconds to see
Would 1 over 3k simplify to 2?
Say that one more time.
Would 1 over 3k simplify to 2?
So if you're not doing this, you've really got to put those numbers in to see it. It's 1 over 3 times 3 halves.
Yeah, and
And that's 9 halves on the bottom. So you flip it, it becomes.
Oh, okay. 2 over 9. Okay, so I got 2 over 9, 1 over 6, and 2 over 15. I think that's right.
Okay. Yeah.
Right.
The, okay. So now this is where, oh boy, what are we gonna do here? Well, you got to make common denominators. So like sometimes these help. Like, see how there's a 90? I'd probably suggest doing 90. So this is 20, 6 times 15, so that's 15, and then 6, so that gives you minus 12 equals A. So what does that become?
23 over 90, but then it is 90
Then you
over
got to flip
23.
it, yeah. All right, so we're going to do one more, but this time I'm not going to have the multiple choice included.
Okay.
Oh no, right? Because there is free response on your SAT/ACT, just like in your exam, there'll be free response, and there is value in actually just doing these problems without multiple choice, especially if you're practicing the concept. So this one's got some negatives too. So give this a shot. This is probably your last question, but I think you can do it. And
Okay.
this is kind of a skill that you'll need for.
Okay, I got 47 or 100 over 47.
Close. There's definitely 100 involved here. So the first one is -1 over 4 times -5/3. This becomes 3 over 20. Did you get that?
Yeah.
Plus, I'm going to put the negative up top, -1 over 5 times -5/3. So this is 3 over 25.
Yeah.
And then the last one is 1 over 3 times negative 5/3. Threes cancel and you get minus 1/5.
Oh.
Okay, and that helps because you got it. Then you make 100, 100, 100 here. And this becomes minus 20, 12, and then 15. 27 minus 20 gets you down to 7 over 100. Then you flip it to get 100 over 7.
Got it. I just did positive 1/5 instead of negative, so almost had it.
All right. Well, I think that does it for us tonight, and I think you are actually very well prepared for your exam. I'll send you the notes and the screen recording out later today, and thanks again for scheduling. I'll see you next time.
All right, thanks, Matt. See
Have a
ya.
great night. Bye now.